Okay, hello everybody once again. Now I will be in a little bit different role than half an hour ago, and I will talk about research I have done for fun, because I think researching for fun is a very good thing to do, because you don't have the stress of writing paper and you can enjoy the working on the research very much. I will talk about paper surface efficiency and inkjet color reproduction on invasive and agro residue papers. These papers are something our institute is working on very actively, and my history in color reproduction and this new topic regarding this kind of papers came together very good. So I decided to make a little bit revisit the history of color reproduction and standardization through these new type of materials. So as I said, the motivation for this work was sustainability and circular bioeconomy, because this has to be addressed for future generations. And this is connected in this paper with the use of less chemicals and to use more recycled materials, more residue materials in circular fashion. Paper industry is already doing it on a smaller scale in some segments. But one trend that I don't like as a printer and scientist or researcher is that commercial and package printing is very often goes towards standardization based on large-scale pulp production, which is when the brands focus solely on the image appearance and the whiteness, the gloss, the shininess. It's the up must without any concern for the environmental impact of this image. So my idea was how to find a way to more accurately to accurate the color image, the color reproduction on papers which are out of scope of existing paper standards. And which tools do we have when we are working papers which are not suitable and are not in the standardized paper groups. So very briefly about color reproduction on paper. As we all know, color reproduction printing is governed by interaction of light, some color reagent, which can be pigment or dye, and the substrate. And working with people from paper industry and my history in printing, I noticed there, as in real life, every paper has two sides. So on the left is the paper maker side of the paper, and on the right side is the printer side of the paper. And everybody's looking from their side of paper. And more often there is no good interchanging of information between the two sides. The paper makers are mainly concerned about the so-called runnability, is the mechanical properties on press or digital system, and are measured by dimensions, mass per area, roughness, stiffness, fiber direction, water content, rub resistance, picking strength, and so on. While the printers, and I think very large part of the also printing industry, is all about printability, the optical properties, the interaction with the colorant. They are measuring roughness, porosity, pore size, formation, brightness, whiteness, opacity, fluorescence, because these properties influence the LIB values, they influence the delta U values, and this is what they communicate with their customers further. But to standardize paper, you need both sides. You need to know the left side and the right side to have a complete paper, which will be also good, have good runnability and good printability properties. So where did paper types or printing conditions in ISO standards, for example, 12447, for example, for offset, flexo, or for the G7 method, where they came from? How did they were built? This was also a very good question for me, and I had to dig a little bit because there is two ways of building a standard based on paper as a substrate. There is the EU way, which is based on paper grouping, and the USA way, which is process agnostic approach, They are concerned, is it, for example, magazine printing? Is it high-class printing? While the EU approach more focused on the types of papers which are used for this agnostic approach of standardization. So the EU spearheaded the standardization. As we all know, FOGRA has been doing a lot of time. And then when it was ISO certified, there was a paper dam group who was responsible for the paper side of the printing standardization. And the EU first proposed these paper types, which came from a paper industry, as I said, the left side of the standardization, where they created something called the paper matrix. Paper matrix looks like this, and this is the basis for all printing standards where we're using paper as a substrate. So as you see, they created something, what is called surface index, which is the interaction of paper surface roughness and the paper gloss value. And on the x-axis is the whiteness as an optical result of the interaction of surface roughness and gloss. And they have made a review of all papers on the market. They charted the results in this way. And as you can see, they define what is the uncoated paper, what is the magazine uncoated, magazine coated, coated premium. And based on these clusterings of paper types, FOGRA developed their profiles. And based on these FOGRA clusters, the ISO standard defined the so-called paper type 1, 2, 3, 4, 5, 6 NLs. So this is basically the bedrock of all printing standards. I don't know how many people from the graphic arts, from the printer side know this, but these are the building blocks of the printing standard. I have to dig quite a lot to get these informations. So how does the paper interact with light? For example, the glossy coated paper has minimal absorption. Uncoated papers, where you don't have calcium carbonate or kaolin, has high absorption. And when you have minimal absorption, the main optical effects are the specular reflection and some part of the scattered reflection. So basically, you're dealing with gloss and smoothness or roughness, and brightness and opacity. And these are the things that have been checked, for example, in this paper matrix. But for uncoated paper, where you have just some surface sizing, some fillers in the structure, not on the surface to enhance the optical properties, you have also scattered absorption, which influences the color and opacity of the fibers and the materials which have been used. So back to history. In the 1960s, previous century, Preusil developed a formula which he called paper surface efficiency formula, and I was very intrigued by this formula because I asked myself, how can a paper be efficient? He included the geometrical reflection, the specular reflection from the surface as a gloss component, and the ink absorbency value in percentage, and he developed a formula which you can see here on the slide. And based on these two measured values, the paper gloss and the ink absorbency, he made the first initial groupings or the matrix of different paper types. And as you can see, papers which have low absorptivity and high paper gloss have a high paper surface efficiency, and paper which are uncoated, they are absorbing more ink, and they have a low paper gloss, and they have a low value of paper surface efficiency. So this was a way that you can, from paper mill, measure the value of absorbability and paper gloss and predict some kind of future behavior of the paper regarding printing quality, because how would it interact with, for example, printing ink? Or if you would make some changes in the mixture of the paper, you could use it as some kind of tool to make some adjustments. There was also several modifications also in the last century and some in the newer century. This is the new paper surface efficiency formula, where they included the print-parter surface roughness, which is similar to the tools they used in the paper matrix, which is the basis for the ISO standards. And also there was some additional changes used by Yang, Ho, Sao, and Liu in the 2010, where they included the whiteness value. But basically, whiteness is interchangeable with gloss, and roughness is interchangeable, for example, also with gloss, because there is a high linear correlation between roughness and gloss. And what was the burning question: how did they get these formulas? Because on the published paper, you don't have the mined model for these modifications. You just get the final formula and the result. And I was very curious. As I said, I was doing this from my hobby, for my pleasure. And I turned a little bit the story around. It is, or it was, a big offset world. So the most dominant printing technology in the last 40 years, as we all know, is the offset, and offset was the solely focus of any kind of standardization, and it needed a long time of to be standardized, and it's already standardized in 2 different ways, or to the neutral scale, or to the ISO values. And both the papers, as I've shown, and the inks were standardized as a building blocks to build a big paper. And all the formulas I found during my research were optimized for offset printing and offset inks. So how the offset inks differs from inkjet inks and dyes? For example, in toner printing, the color particle just sits on the paper. The paper has small influence on the final color, mainly the roughness. There is no much absorption and interaction in this internal scattering. In offset, you have the separation of the ink vehicle, which is sucked in by the porous structure, and the ink pigments which are left on the surface, and their planar alignment is basically what changes the light and makes the optical properties, which we measure with CA, LIB, and delta, and so on. But the greatest difference in paper caused by paper is in inkjet technology. I'm talking about the water-based inkjet technology, not the UV LED, which basically makes a plastic surface on the paper, because it's absorbed into the structure and has high internal scattering and influence on the final color reproduction. So what is the color of white papers? And this is also a very burning question. The so-called perceived higher quality of papers have more bluish colors, minus B values in the CA-LIB system, while lower quality papers are more yellowish. And paper people have used whiteness because it was easier for them to make the grouping than the 3-dimensional LIB values. So here we can see, for example, a very high quality coated, very white paper with high whiteness. They have values around 120 with some extreme 150. And as we are going towards newspaper printing, the whiteness value is dropping, and also the LIB value is going from the -B to the +B very much. And our papers I will present are basically under 50 whiteness value. So I'm talking about papers which are on the edge of this trail. So they're out of focus, out of this main axis of standardization, because they have a very low whiteness values and they have a very high paper color or paper tint, and I was interested how can I standardize in paper making this value that I can predict if I can come into the main axis. So as I said, we are producing papers from sustainable sources as invasive plants from urban cut or agro residues, and our main idea is that we want to have a green change and green technologies. That means to use as less as fillers and less bleaching chemicals to achieve whiteness of the paper. And this comes back to the matter of perspective, the perception of quality. Why we perceive a white as a very good thing, and for example, yellow as something that is not so qualitative. For example, everybody likes a light, not everybody, but most of people like white walls, because if they see it's starting to get yellowing, it's part of the decaying process. It's also connected with the double bonds in the chemical structures, which bends the light. And for example, with bleaching, you destroy these double bonds, and then you have a whiter paper, bigger reflection, and things like that. But for example, many people don't wear white clothes, except for example the medical people. So this whiteness as a chosen way of quality paper is maybe something we can discuss, or if we have sustainability, of course, in mind. So what have we done? These are the papers we produce here at the institutes. We made paper from youth bags, weight bags, miscanthus, Canadian goldenrod, it's an invasive plant, black locust also invasive plant, tomato stems from agro residue, and Japanese knotweed. And we printed it with an inkjet printer. We measured the color, we measured the paper, and I also measured the ultrasound absorption of liquids. I used water and 16% of isopropyl alcohol to mimic the inkjet ink, because I couldn't put the real inkjet ink into the ultrasound measurement machine. And these are the results. As I said, our values of whiteness used for standardized paper are on the lower edge at around 60. So we are below that. We are in a very unspecified region. I measured the gloss. The gloss is very low. And then I measured two parameters about absorbency. This is the equivalent of Kobunger. And this is parameter which is specific to this measurement instrument. I put these values into the classic Preutzil formula, and I used the modified formula for 2010, and I calculated the paper surface efficiency values. You can see them here for different kinds of papers. And here are the colorimetric values. So the youth paper, miscanthus, Canadian goldenrod, black locust, tomato stem, and Japanese knotweed. And I calculated the delta A 2000 values from an ideal cyaning. I didn't take any standardized paper. I took a LAB value of a standardized ideal cyaning, and how far will I be regarding the paper properties on these agro and residue papers we are producing. And for example, you can see that the delta A 2000 value is 12 for the lowest value, and it's very well connected with the L value, because youth has a very high L value, not very high, but the highest in this group of paper, while for example, the highest color difference value for black locust resulted with the lowest L value. So there is, of course, the interaction that the lightness is a very strong influencing factor on the color reproduction on this kind of papers. So I took the paper surface efficiency formula. I didn't use the original values proposed by Preutzil, because he used the key K and ink absorption value for offsettings. I use the A30 parameter, which mimics the surface absorption capabilities of papers, and I put it in the formula. So this was my change, and you can see I got a really nice correlation where I can predict that paper surface efficiency is very well correlated with this my modification formula with the delta A value. So if I measure with this ultrasound method, and I measure, for example, the gloss of the paper, and I put it in the formula, I can predict with a very good certainty how would this paper which is out of all standards, be able to produce most accurately, for example, an ideal cyaning. So this modification was very useful, and we will use it in our future production. As you see, it has a very good R2 quality, and also I calculated the R% coefficient, which is even higher. So there is a very good coloration by using not the modified version, but the initial version of Preusil, but changing the ink absorption value, which was for the offset papering, with the absorption values a little bit modified by me and by us for the inkjet printing. So as a conclusion, I will say that classic whiteness-based solutions for non-standard papers like our papers, which are uncoated and are unbleached, are not working. So we had to find a different way. As I explained, we changed the original Preusil formula ink absorption value to A30 value, and this provided excellent linear coloration. And this can provide info on color difference magnitude for inkjet printing. I will say magnitude, not on correctness. So it is a very rough tool, but you know in which quadrant you are. It's a very good tool for paper printing optimization. And what we are planning in future, when I will have time to have this fun side projects, is to further investigate the paper shade influence on the total color difference, where, for example, high L value, high chroma value, low delta hue angle value resulted from high gloss and high absorption values. And I want to also test the influence of ink penetration in inkjet printing on all these different kind of results which are stemming from these measured properties. I want to thank you all for your attention, and if anybody has a question, I'm be eager to answer.